Alright, so we're a little bit behind with our video, but if you're watching this, you can see what the answers are to the notes at the top. We're talking about simplifying negative square roots, and in order to do this, we just have to know that the square root of -1 is equal to I, which is the imaginary number. So if I simplify the square root of -192, I'm going to break it up into -1 times, what is the largest perfect square factor?
64.
64.
3 and 64.
So 64 and 3 are the factors that we would choose for 192. The square root of -1 is I. The square root of 64 is 8. So 8I root 3 is our simplification.
Coach Snyder.
Yes, sir.
I just noticed something that you didn't put, that the paper wasn't on that back of this time.
Yes, it wasn't. You're exactly right. Now, I do want to emphasize that, I didn't say, we talked about this earlier, but not on the video. When I'm finding the square root of just numbers, I don't have to put plus or minus. I only have to put plus or minus if I'm solving quadratic equations. Because if it's dealing with a quadratic equation, you have to have two solutions, which means if I take a square root, it's got to have the positive and negative version of that root. So in number 7, we're going to subtract 81 from both sides, just like we did yesterday with these. X squared equals -81. Take the square root of both sides. And x equals plus minus what? 9 what? I. Okay? So, you deal with the with the numerical part, the non-negative part, if you will. You deal with the 81 exactly the way you would deal with the stuff from yesterday, as if it were not negative. And then you deal with the -1 by taking the square root of it, which is I. Okay, number 8. Let's subtract 9 from each side. 2x squared equals -8.
X squared equals -1.
Yep.
I put x equals 2i.
That's correct. X equals plus minus 2i. Alright, y'all try number 9 off the video. Alright, so we're going to subtract 15 from each side. 4x squared equals -24.
So you divide 4.
Yep.
X squared equals -6.
Take your square root of each side.
And x equals plus minus I root 6.
Excellent. Since you cannot simplify the root of 6, you leave it. Now, a lot of students think you can simplify root 6. But 6 is not a perfect square, and it doesn't have any factors that are perfect squares.
Whoa.
Alright, number 10. Let's just do it together. Subtract 13 from each side. X squared equals -12. Take square root of both sides. X equals plus minus. The root, well, let me simplify it over here. -1 times 4 times 3. So I is 2. So you're going to have 2i on the root of 3. Alright, let's flip the page. Okay, numbers 13 and, 11 and 12 are just more of the same. Let's go ahead and just do these together real quick for time's sake. So we're going to add 5 to both sides. 3x squared equals -441. Divide by 3. X squared equals -147. Take the square root of both sides. Okay, so let's think a minute what the factors of -147 are that we would need to use. So I would start by dividing it. It's not divisible by 2, so do
3 is 49.
3 and 49.
What, 9?
So, root of -1 is I, root of 49 is 7, so 7i root 3. 7i root 3. Alright, number 12, add 1 to both sides. -2/3 x squared equals 18. Now, I told my class earlier that if you can do this problem, or one like it, then you pretty much have mastered these things, these concepts. Okay? And this is not complicated. There's a couple ways you can approach this. You can multiply both sides by the reciprocal of negative 2/3, which will be negative 3 over 2. Or you can multiply both sides by 3, or negative 3,
Look, Newsom, come to the front office.
and then divide by 2. Either way, it doesn't matter. Okay? So if you multiply both sides by 2/3, by negative 3 over 2, what happens is the fractions cancel on the left. That leaves x squared equal to, alright, 18 times negative 3 over 2 is going to be negative, negative 3 times 9. Because 2 goes into 18 9 times. 9 times negative 3 is negative 27. So take the square root of both sides. 9 and 3. So you're going to have what?
X equals 3I root of 3.
Excellent. Y'all are getting good at this. So the more of these you do, the less scratch work that you have to do, because you know that the root of 9 is 3 and the root of negative 1 is I. 3I root 3. Alright, now, we're going to pause the equations for a minute, and we're going to change gears again and talk about exponents of I. Because I is a number. Like we said before, I is a number. I is the square root of negative 1. So what happens if I start raising the I to different exponents? What values am I going to get? So let's work it out. Let's figure it out. Alright, so here we go. We're going to see that there's a pattern that develops here. Let's start with I to the first. What is I to the first? What is I? Square root of what? Negative 1. So I is the square root of negative 1. Okay? But do I need to write square root of negative 1 if it asks me what I is? No. I is just I. Okay? Now, when I square the I, that's like saying the square root of negative 1 times the square root of negative 1. So the square root of negative 1 is?
1.
No. The square root of negative 1 is?
I.
Well, let me back up. I didn't say that right. When I square a radical, the result is whatever's underneath the square root, right? So what's negative 1 times negative 1?
1.
Negative, I said that wrong. What's the root, let me use a different example. What's the root of 3 times the root of 3? 3, right?
Yeah.
So the root of negative 1 times the root of negative 1 is just negative 1. Okay? We'll get it straight. Okay. The next one, I cubed. So I cubed is then going to be negative 1 times I. Because I squared is negative 1, and then I cubed would be I squared times I, which is negative I. Okay, so I cubed is negative I, and I'm going to multiply by another I. So what do I get when I do negative I times I? Well, negative I squared, right? Okay. So what was I squared?
Why you putting it right up?
Look, I'm just taking the one before and multiplying it by another I. Because that's what this is. Alright, so what is I squared? Negative 1, right? So what's negative 1? 1. Okay? So we've got 4 different values here. I to the first was I squared is negative 1, I cubed is negative I, and I to the fourth is 1. Let's keep going and see if a pattern develops. So we know that I to the fourth is I, right? Is 1. So 1 times I is what? That's I. Wait a second. I times I. Negative 1. Wait a second. Negative 1 times I. Negative I. Wait a second. Negative I times I.
1.
1. There's a pattern. You see the pattern? The pattern is repeating every 4 exponents. If I go through 4 more additional exponents, increasing by 1 each time, I'm just repeating those 4 things over and over again. So what would I to the 9th be?
I to the 9th would be I.
What would I to the 10th be?
1, negative 1.
What would I to the 11th be?
Negative I.
What would I to the 12th be?
1.
Okay, so there's this pattern that's developing. So there's only 4 possibilities.
So you only need to know 4.
So you only need to know 4. These are the first 4 and the 4 that you need to know. Alright, now, it's good to memorize those. I don't think I'm going to make you memorize those, but it's good to memorize those. So here's the thing. What if there is a much larger exponent? Let's say we had I to the 1,331. Oh my goodness, what am I going to do? Okay? Alright, so, how many possibilities are there? 4. So all I'm going to do is divide this number by 4 and figure out what the remainder is, if there is a remainder. If you go back to elementary school for a minute, if I divide by a number, you're either going to have no remainder or some remainder up to whatever you're dividing by. In other words, if I divide by 4, how many possible remainders are there? Think about it. There could be no remainder, remainder 1, remainder 2, or remainder 3. Is there a remainder 4 if you divide by 4? No, you can't. It's just 0. Okay? So, there are 4 possible remainders. 0, 1, 2, and 3 if I'm dividing by 4. Those remainders are going to match up with these exponents. So all we have to do is figure out the remainder. So 1,331 divided by 4. Somebody put that in a calculator. Tell me what you get. 333.75. Now, the .75 part, that's your remainder. It's 3/4, right? Okay? You said 332 or 3? 2. Alright? Okay, now, if I want to go directly to my remainder without having to think very much, there are multiple ways to do this. This is just one way. If I want to know what my remainder is, I'm going to multiply this whole number part of this decimal by the 4. That's going to give me 1328. Alright? Subtract the 1328 from the 1331. So 1331 minus 1328 equals 3. That is my remainder. So if 3 is my remainder, I go to I to the 3rd.
It's negative I.
And my answer is negative I. There's only 4 possible answers. Okay, so it's just repeating itself over and over again. So how would we do it if the exponent was 15? 15 divided by 4 equals what? 3.75. So multiply 3 times 4 and you get what?
12.
So 15 minus 12 is 3. My remainder is 3. So I go to I cubed and the answer is?
Negative I.
Negative I.
But you can also look at your remainder.
Yes.
0.75.
Yep. So if you look at .75 and convert it to a fraction, what is it? 3/4. If you're dividing by 4, there's only 4 possibilities for what your remainder could be. There could be no remainder, which means like 16 divided by 4 is 4, right? There could be a remainder of 1. 17 divided by 4 will be remainder 1. 18 divided by 4 will be remainder 2. 19 divided by 4 will be remainder 3. And then it starts over. 20 divided by 4 is no remainder.
You can say 0.25, that's 1/4. That's
Exactly.
1/50, that's 2/4, that's 2.
Yep.
75 is 3/4, that's 3. And then we're going to wind up with just 1 then. 1. You don't have to worry about the fractions or anything else. You can remember
Exactly.
25 cents, 50 cents, and then
If you can, yeah, exactly. 25 cents. How many quarters are in a dollar?
4.
4 quarters. So there's 4 possibilities. So if you got a .25 right here, that's 1/4. So what is my remainder? 1. If you got a 2/4, that would be .5, right? So my remainder would be 2. So you don't have to do all this. This is just one way to do it. All right. Then you got 4/4. Well, you okay? That's a 1. All right? So that tells me that I'm going to look at exponent 4. All right, let's do 60. Y'all do I to the 62nd on your own. All right, so I to the 62. You do 62 divided by 4, which is?
15.5.
15.5. Now, this .5 tells me that that's 2 over 4. 2 over 4 tells me that my remainder is? 2. So I take my 2 and I match it up with the exponent 2
It's
and
negative
get
one.
-1. Huh? That's another way to do it. All right, we're going to stop the video here.